Hi, wanted to do a quick little review of the equations that we came up with in class. So if you recall, we had the velocity graph and the position graph, and it's clear that the velocity graph is linear, and it's clear that the position graph is some kind of curve. And what I want to do in this first video is sort of the simple version of what's behind why we use the equations we use or where they come from. So in the position graph, when we had a line, we had at this point the y-intercept was the starting position. Since this is a velocity graph now, this is clearly our starting velocity. And we're going to write that as v naught. That little zero means naught. The slope tells us our rate at which we gain or lose speed. Well, we have a simple term for that. It's called acceleration. And we'll write it with the letter A. So we're not going to write this equation as y equals mx plus b. We're not going to do that for this line. That is a no-no. Instead, we're going to write the final velocity, the velocity we want to calculate, depends on the acceleration of the system and the time for which it accelerates, and it depends on the speed we started at. So this is the first equation that we're going to do. Now, it turns out we learned that how far you end up depends on the area underneath this graph. When we actually calculate that area, it turns out the position as a function of time is going to end up being a function of how much you accelerate and for how long, plus the speed you started at and the time you travel, and where you began in the first place. So that's the second big equation. Oops, I don't like that. Whoops. Sorry about that. And then we have a third equation where we can actually combine these two equations. And the third equation, which is a combination, is given by this weird looking formula here. Okay. And what it basically says is, look, when I give you a story problem, and if you don't have time, you can use this formula to help you out. So these are the three equations that we're going to be using to solve story problems in class. I don't know why I call them story problems. I feel like I'm talking to you like you're in 5th grade, but I just kind of want to distinguish it from problems where we're only looking at graphs. In the next video, I want to actually talk a little bit more about where this formula comes from for those of you that are curious.